we now stream on YouTube. So if you guys are virtual, then you guys can join on YouTube to watch the stream. I can call you up if you want, or you can stand up here with me. Did you get like hit or something? Like here? Yeah. Oh man. All right, guys, we're gonna get this meeting started. Welcome to RITSEC, Security to Your Community. This is not my slideshow, by the way. This is on yours, not mine. Yeah, I'm sharing. Oh, that's not right either. Okay, let me redo it. One second, guys. Technical difficulties. How did week 3 go for everyone? Good. That was week 3, right? Now we're going to week 4 next. Dude, shout out to Berlin Donor. If you guys never been to this place, it's really gas. It's like gas station food, but if it was really good. Jesse's got it. They give you like a rice bowl with some chicken. All right. Looks good now. All right. That's all good. All right, guys. Here we go. We're going to get started now. Welcome to RITSEC, guys. Week 3, Security to Your Community. Make sure you join the Discord if you have not joined the Discord, because you do need to sign in order to get pizza. Everyone all in? All right, guys. Make sure you sign in now, because I'm going to be checking later when you guys want pizza. You must be signed in or else you're not getting pizza. If you guys don't know where that is, raise your hand. All right, guys, check the calendar. We got some cool events coming up, which I'm about to announce right here. What? Oh, yeah. Guys, we got to drop the sign in if we didn't know that. Where's my fellow e-board? Who could do that? Uh-oh. All right, guys. Sign in will be dropped. Will be dropped in a second, okay? But let's keep going. So check the calendar. Make sure you join the mailing list as well. And here's for announcements, guys. Clap it up for the sponsors, guys. Come on, clap it up. Clap it up. Let's go, let's go. All right. Make sure you follow our social media. And we have RITSEC Black Team signups. Right now they need to fill in scoring and store. In the competitions on November 1st. And this form closes on Monday night. Same thing with Blue Team. Yeah, the Blue Team workshops are being held throughout the week before the competition starts. You guys can join in as a team of 5, or you could be a free agent, and you could be assigned to a team. So make sure you guys get on that. Yeah. When did they close? I'm putting the slide, so I have to check back. It's in the announcement on Discord. Yeah. Message Ariana about that, and sign up as 2, and then say like we signed up as a team as 2, and we're looking for free agents to fill up the rest of the team if that works. If you guys get selected, they'll fill up your team, but that should definitely be made to happen. And yeah, CCDC info session happening after the meeting today. That's right, James, right? Okay. Make sure to check that out. Be there. Now we have Intro to Linux by Odessa. Clap it up, guys. Clap it up. Good presentation coming for you.
Hello. My name is Odessa, and I'm doing Intro to Linux today. So, starting off, who am I? I'm Odessa, she, her, third year CSEC. I taught Ducky's mentorship last year and was a Ducky mentee the year before. Hopefully current Linux black teamer. I'll ask Ash later. Enjoyer of loud music and live music. Go to way too many shows, including this weekend and next weekend and the weekend after that. I daily drive Void Linux, which if you've never heard of, congrats. Good job. You shouldn't hear from it ever. And this will hopefully be the only time I mention it this presentation. Go to VRig. Big VRig enjoyer here. And I also use Windows, much to some people's surprise. So starting off with some background. What is Linux? Linux itself is a kernel, open source kernel. It is not an operating system. You have different Linux distributions that sit on top of the kernel, and those are your operating systems. Some of these include Ubuntu, Fedora, Kali, Arch, and shout out to Garrett, the sysadmin professor, Red Hat Enterprise Linux. Shout out to Garrett, physical lead too, I guess. Why use Linux? This is a question I get asked all the time. For starters, it's open source. That means all the packages, most of the packages and the kernel and most of everything is out there online for you to look at. You can go look at the source code, you can go poke at it, write your own versions of it. It runs on everything. Mainly what people use it for are servers, but you can get it to run on any ancient laptop, any ancient computer you have lying around, or even your car. If there's a processor, it can probably run Linux. Linux is command line focused, meaning that you can do everything that you could in a GUI from the command line. This is also possible with other operating systems like Windows, but in Linux, it's intended that you use some of the command line for everything. Some of your Linux experience will be only command line when you don't have a GUI at all. You have a lot of different package managers. It's how you get different packages, different programs to run. Some of the main ones that you'll encounter are apt, DNF, and PKG. Pacman if you run Arch, but most people don't. And it's a multi-user session operating system, meaning multiple people can be using one machine at the same time without running into each other. This is really useful for servers. Not so useful with your personal computer, hopefully. But again, servers is where Linux really shines. So diving a little bit deeper into the shell, it's what allows you to access the internals of your operating system. A lot more powerful than most GUI tools. Most GUI tools are sort of wrappers for what you can do in the shell. Some examples of shells you have are Bash. That's what comes pre-built with most operating systems. ZSH, it's a popular Bash alternative. Allows for a bit more customization than Bash. You can do some cooler things with it. SH is very basic shell. If you ever get unfortunate enough to be dropped into TTY1, you're going to be dealing with SH. And then my personal favorite, Fish, which has the most amount of customizability of any shell I've found, but also deviating a lot from what Bash sets up. So your prompt, by default, will give you some basic information. It's customizable in a config file called your bashrc or zshrc. For example, mine on my laptop is Odessa@void. Odessa is my username. So depending on which user I'm logged into, that will change. And then void is the host name of the machine. And then next to it, that little tilde, that will get replaced with my path, or my current working directory, I'll say that. And You can interact with the shell through like the default built-in shell, but normally when you exist in userland, you'll interact with it through your terminal. By default in Ubuntu, that's the GNOME terminal, but some alternatives are Kitty, WesTerm, Console, and Tmux. I know there are Tmux enjoyers here. Not a fan myself. So in the shell, who, what, where, what's going on? To start off, there's the ID command. Type that in, and you get your user and group information. We'll go deeper into what groups are later, but this has a lot of different information about who you are, what permissions you have. The pwd command stands literally print working directory. It'll print out exactly where you are in your file system. IPA. Oh, no TAC A, interesting. IPA, it shows network information, your IP address, different things that you can use if you're diagnosing network issues, which you will be. And PSOX, this is used to look at process information. So what processes are running, who's running them, their process ID, parent processes, how long they've been up, permissions the processes have. Very good for diagnosing issues if you don't know what's going on. What does this do? So there's these things called man pages. For every command, there should be a man page associated with it. And to check it out, you type in man and then the command. Very simple. Think of it as built-in documentation in the machine itself. You don't need internet access for this. It's all locally on your computer in user share man. And it's really good because that is how you figure out like what all these different options do for different things. Something else you can do to figure out what commands do is the command apropos. If you type in apropos and then a keyword, it will print out everywhere in the man pages that this specific phrase exists, like every page that has that phrase in it. So if you type in apropos SSH, for example, it will put out a list of every single man page that has SSH in it, which can be really useful. So that's a basic overview of everything you'll be doing in Linux. Start diving deeper into the file system. So the Linux file system exists in a tree-like state. You'll see it shown different ways, but it all starts from your root directory, which is the slash. Inside your root directory, you have a bunch of different root level directories. We'll get into some important ones later. Your etc one is really important, etc. But from there, everything is a file. Although you can change directories, those are files. You can look at different files. Sockets are files. Processes are sometimes files. They're a weird state when they're running, but from your root directory, everything exists inside of that you can think of on Linux. And just some terms. Relative paths are paths to different places in your file system, starting at where you currently are. So if I was in a directory in my pictures directory, I would go back one to go to my pictures directory, back one to go to my home directory, and then I could change into whatever directory I wanted that's in my home directory. This differs from absolute paths where you start at your root directory, you start with the slash, and that will take you directly there from wherever you are. So going deeper into paths, once again, you have your slash, which is your file system root, the etc directory, pronounced etc, or etc. It confused me the first time I heard it. It's where all of your, most of your configuration files will be for your system. You'll end up here a lot when you're debugging weird processes. Your home directory is where all of the different user directories are. So, for example, like when you log into your student account on RLS in your whatever VM you have, when you open up the terminal, you will be in home/student. Your proc directory has information about what's on your system, what's running on your system currently. You can dive into that deeper to find out more. The /bin, /userbin, /sbin, and user sbin contains all of your binaries, all of your different commands that you can run. That is where they all live, or should all live, ideally. They each have their own specific use cases of why something would be in bin, user bin, but for all intents and purposes, you don't really have to worry about that. Those four are where all of your binaries will be. The var log directory is where a lot of your system logs are going to be. A lot of processes by default create a directory in there to send their logs to. Logs can be annoying to read, but I promise you they will be very useful later. Yeah, the tilde, the little squiggle, that is what's known as your home directory. If you see that in your terminal, you're in whatever user you're logged into, their home directory. That's where downloads, documents, pictures, desktop, music, and videos will be, those defaults that you're used to seeing. And about the relative paths. The dot, the single period, that is your current directory. That's where you are. And dot dot is one level up, so the directory before where you are. Navigating said file system. CD stands directly for change directory. If you just type out CD, you will go back to your home directory by default, but CD downloads will take you to downloads. CD ... etc will take you to the root level etc directory from your home directory. The ls command lists everything in a directory. It's how you see what's in there. Ls tac a lists all the files, including the hidden ones. Ls tac l gives you additional information about each file in each directory. For instance, who can access it, who can read it, and LA for both. The cat command prints out the contents of a given file. Syntax is cat file name. It's very simple. It's how you can read a file without actually having to go into an editor to open it up. Other methods to do this, you can do some stuff with echo. The less command will show you certain lines. The head command will show you certain lines. Importantly, the file command, just typing in file and then the name of a file will print out exactly what type of file it is. So in the image up there, I ran all these commands in my home directory. So CD to get back to home, ls listed out all the directories in my home directory, or all the files rather, in my home directory. I have a file in there called example. So when I ran cat example, it printed out the 2 lines in that file. And then when I ran file on example, it's telling me that it is a bin bash script, an executable. A very important tool you will learn somewhat how to use is the find command. This is how you can locate any string on your file system anywhere. The syntax is find, and then the starting point, and then whatever options you want to give it for how you want it to search. Listed out a couple of these ones here that you'll find useful, but the man pages are definitely your friend for this. There are a lot of different options for find. It's a very powerful tool. So starting off, the tac name just lets you search for things with that name, or iname. I'm pretty sure that is in the name, so a bit looser, but still when you're searching for a string. Tac type allows you to search for files of whatever type you specify. So executables, config files, videos, you can filter, essentially how it works. Tac perm is searching for different permissions. We'll go into what permissions are a little bit, but essentially think of it as who can access what and how. So you can search for files by specifically what permissions they have. You can search for them by the user or the user ID. Find files owned by this specific user. Same with group, owned by the group or that group can access. And then tac mmin is find files that were edited within a certain amount of minutes ago. And the which command allows you to find exactly where a binary is on your system. You run which and then whatever command you want to find. This is where you can find if it's in user, user bin, or bin, user bin, sbin, user sbin, those 4 directories. Diving more into users and groups, it's how access control is handled for Linux systems. Each user has a specific number associated with it. That's the user ID. Among other places, this information is stored in etc password and etc shadow. As you can see in the first screenshot, that is the first line of my etc password. You can see root and its user IDs, which are 0. And also the default shell that it uses when you log into it. For me, that's fish. By default, I believe it's sh, but you can go in and change that. For groups, every user has a primary group that's associated with it, and then you can add up to 15 other secondary groups, and each group works relatively the same. They have their own ID, and they're how you organize different users. So for instance, the users that people log into, we're using the word users a lot, but those specific users will all be in the user group. Whereas you'll have the Docker group or the sudoers group, for instance, and the Docker group can control Docker and use Docker commands. Sudoers group has access to the sudo commands, so you can do things as root. And all that information is stored in etc group. Continued going on to sudo. Sudo is your super user. It's how you can run commands as root. Root can do basically anything on your system. Anything in userland it can do. It's configured in the etc sudoers file. You can edit that using vi sudo, I believe that's the command. And sudo tac-l is how you list the privileges, what you can do for the current user you are logged into. Some helpful commands for users and groups are usermod to help modify some specifications of the user account, so like what permissions that user has. Useradd is how you create a new user through the command line. Userdel is deleting one of the users from the command line. Groupadd and groupdel, same thing but for groups. Chmod or chmod, changing file permissions, changing it to be executable, changing who can read it, who can write to it. And chown or chown, changing the owner or the group of the file. Going more into file permissions, this is how you specify what users and groups can do what to a file. So here we have an example. In yellow is the type of file. So it's a directory, a link, or normal. If you look in the screenshot, this is a file. This is a directory in my system. We have in there, you can see the string at the front where it's R, W, X, and all the dashes. For the normal files, it's just the dash. For directories, you can see the D, and for the symlink, which we aren't going to go into in this presentation, it's an L. They're a little weird. The first 3 letters of the permission string are for the owner. So what the owner of the file can do, you have read, write, and execute. The second 3 are for what the group can do, the group that the user is part of, the main group, so read and write, but not execute in this case. And then what's in red is what all the rest of the users on the system can do, and that's just read. So in this case, if that's my personal account and I am in the users group, I can read, write, and execute whatever file we're looking at. Other people in the users groups can read and write, but they can't run that file. And any account that isn't in the users group, so like if for some reason someone in the Docker group, only the Docker group is trying to or that account is trying to execute the file, they won't be able to, which is good because no one should be using that. Yeah, file permissions will also be very important for later. Interacting with files, MV move is how you move files around and rename them. RM is for removing files. CP, copying. You can copy files and directories. mkdir is for making a directory, literally make dir. Less allows you to scroll up and down through the file. Pretty sure that uses Vim keybinds for those who know what that is. Tail and head, you can add a tag number after them, and you can output the first number or the last number of lines in the file. Useful when you don't really want to have to scroll through a massive file and you know exactly what the lines you're looking for, where they are. And then once again, the file command to determine the file type. Yeah, and then we have a bunch of examples on the side. Can we move this? Yeah, so top screenshot, I use the command mv readme.md flagmd. This moves, or it moves the file from being readme.md to flagmd. That's how renaming works. Little confusing, a little weird to grasp at first that you're moving the file, but it's just the syntax. Once again, running the command, the CP, copying, in this case, my binary ninja executable to be Ghidra as well, binge on top. Checking the file for, in this case, a Windows executable on my Linux system. Don't know why that's there. Nothing bad going on. And then at the bottom, it's an example of the tail command. I'm outputting the last 10 lines of strings.txt in this case. grep. Grep is similar to find in how powerful it is, but in this case you would be searching for strings itself, specifically patterns in a file or patterns in whatever you are pushing into it, whatever you're sending to it. It uses regex, which I don't know if you've encountered that in your intro classes yet. Very weird syntax, not at all beginner friendly, but there are a lot of resources out there, specifically regex101.com. You can make and test out different regular expressions. And these are just here to help filter and edit, almost automate the editing of text. It's very useful for log files, specifically when you're searching through massive log files to find certain strings. If you figure out the correct regex string to write, you can filter everything down to exactly what you want to read. grep can take redirected output, so listing or catting a file, printing it all out, and then sending that output into grep just to print out certain lines. I use this all the time. And ripgrep is another command that you can use that used to recursively search a directory for a pattern. So it sort of exists between find and grep in this case. Has Unicode support. It's faster. Check the man pages. You'll learn all you want to know about it there and more. Going into some other stuff. Some processes, some other things you'll find useful about Linux. SSH. It is the secure shell. It's how you can connect to different shells. In cyber, this is really useful in general, getting access to different machines without having to go up to them physically to log into them. You can install them, I think sudo apt install SSH is how it works. I don't know. I don't use Ubuntu anymore. But you can install it and set it up. It works pretty much out of the box. You do need to set up some configs to fit your system, but once again, it's pretty simple. The syntax for it is SSH username at host. So going back to my original, way back when I showed you my own username and host. in this case, Bingus1 is one of my servers. And so SSH Odessa, I'm logging into the Odessa account on that host. And by default, this runs over port 22. By default, it can be changed. It might be changed. By default, it uses password authentication. So when you run SSH, it'll have you type in the password of the user to log in. But you can set up to use public-private key instead for instant login. It's also way more secure. The command SSH keygen is what you use to generate those keys. Once again, check out the man pages. Just play around with it. It's very simple. Different file editors. Starting off, you have VI and Vim. Vim is literally VI improved. VI comes default on your machine. Vim you have to install. They are optimized for being able to use your keyboard. So they're a little weird because they have different modes. You have insert, you have visual, and then there's one more. I don't remember off the top of my head. Not super user-friendly, but once you get the hang of it, it's really powerful, really useful. By default, most of you will be used to Nano. It is the most user-friendly. You can use arrow keys in the editor. By default, you don't have to change modes. You don't have to do anything. It's just by default, you can edit whatever file. Not necessarily a competitor, but an alternative to VI and Vim is Emacs, arguably more powerful, also hard to learn and get used to. You'll find people who prefer either. I know there's someone here who prefers Emacs. Don't think he's here right now. NeoVim is an editor you'll find some of us in the club preferring. It's Vim, but with a different backend, so it's a lot more configurable. You can do a lot more with it. Talk to Michael Brenner about his NeoVim config, please. I know there's another text-based editor called Helix. I've never used it. I just put it there because it sounded cool. VS Code is a perfectly fine text editor to use. If it's what you're comfortable with, you can launch it from the terminal. You can use it. People will try and shame you for it, but don't let them. It's perfectly valid. And then on Ubuntu, you'll have gedit, which is GNOME edit. If you just by default open a file, that is what you'll be dropped into normally on Ubuntu. Also important, pipes and redirection. Pipes were mentioned earlier in the slideshow. It's how you take strings and move them in and out of being used in commands. So by default, I'll just give examples. So the single caret is the single and double caret are how you take an output of a command and send it to a file. One of them overwrites everything in the file. One of them adds on to the end. I don't remember which off the top of my head, so you'll want to check on the man pages for that, probably. Yeah, so you can see examples down here where you run the find command and then send that to output.txt. The left-facing arrow can be used to input file contents to a command. There are other ways to do it, specifically with the pipe, the big line that's above the enter key or the return key on your keyboard. That actually has a use. And it's how you can take output of a file and then use it in another command. So I said history in grep. In this case, the example is ls-tac-la. And then you take that output, that listing, and then send it to grep for some file or text or some string. Environment variables. At first, I didn't really learn a lot about them, and then they became the bane of my existence. It's how you can store information essentially as variables on your system. There are two kinds. There's the global environment variables, so those apply to everyone on your system. In this case, they can be set on user login through system-wide configs in etc profile or etc environment. And then you have user environment variables, and those are normally set in your shell config. So your bash RC, going back to that, you can set different variables that you'll use in there. For example, your path. For anyone who's ever fought with VS Code on Linux and you have said something about your path is an environment variable that you can add different strings to. For setting them, you can run the export variable in all caps and then the value, or just the variable in all caps and then the value. And unsetting it then removes it. Again, these aren't important until they suddenly are, and you will not expect it, or at least I didn't. Processes. Went a little bit into processes earlier about how they're files, but not exactly files. There's some weird in between. Processes, they're what's running on your system. So in this case, PS, the command PS, shows all running processes and related information. It reads from /proc. Very useful. It's a really useful command. Again, useful for later. Pay attention. Yeah, you'll need it to look at what processes are running, what users started the process, how long they've been running, their path. Then for the opposite, killing a process, something you do occasionally need to do when they aren't set up correctly. It just sends the syntax is kill and then the process ID, although TAC9 forces it, so kill TAC9 and process ID, that will force it to be killed. It won't be able to argue. That is just how to get rid of a process completely. Very, very useful. And then you have a top command, which similar to PS, but top is live. Actually, I don't know if PS is live. Whatever. Top is a bit more interactive. You can check more information about what's currently going on. Some alternatives are HTOP and BTOP. They allow slightly different views, but they're also separate packages. So by default, top, you can check user, the PID, the time that it's been running for, the specific command that is running the process, how much CPU and how much memory that specific process is taking up. Yes? Similar in its use, yeah. So the question, is top similar to Task Manager on Windows? And it's not a mirror, but they're used for the same things. You can also kill processes from top. So if you don't want to deal with the kill command or finding the PID or searching for what's going on, you can run top and you can kill processes directly from top. Going a bit more into package managers now, again, just going through some useful stuff. It's how you install and update your software on your computer. Packages sometimes have, or often have, dependencies, and so your package manager will help you also install those dependencies with the package you want to install. By default, Ubuntu uses apt. Rocky uses DNF, I'm pretty sure, or PKG, maybe both. Misspelled that there, but Pacman is what's used for Arch Linux and all the Arch derivatives. To update software, apt update and apt-get upgrade. Apt-get is a related package, but used for the same thing. DNF upgrade and whatever Pacman string it wants. Downloading files from the command line. So again, sometimes in Linux you don't have a user interface. You don't have something you can click on. So in this case, if you need to get a file, you can use wget or curl. Wget, it's extremely simple. Just wget and then the URL. So for example, if we're downloading from a file server that's hosted on example.com, if you want a file or to the file.txt, it's just wget and then the link. So example.com/file.txt. Curl is a bit more powerful, a bit weirder. You can use this to directly save. You can use it to read strings from servers. You can use the tac-o command to specify the file that you want it to end up as. Like, so you pull a string down and then you send it to a file directly. I prefer curl. They each have their own use case, but learning curl is also very useful. Some tips and tricks for just moving around, getting stuck in the command line. Control-C kills the current command. If you run a command and then it just freezes, just spam Control-C. It'll kill it. It'll stop the process. It'll get you back into an interactive mode. Control-D is exit. So if you're in your user interface, that's how you exit your shell. You close your shell. If you're in a TTY, or this is also how you log out of certain users. So if you're in a user and you want, say you change your user to root and you want to get back to your system user, Control-D runs the same thing as log out. Just a quick, easy command. Control-I on some terminals is how you clear whatever's in there. It works as the clear command. Control-Z is suspending a current process. If you play with Python shells, it tells you to escape is to use Control-Z. You can use FG to run in the foreground and BG to run in the background again. You can list your suspended processes with jobs. The tab key, it's how you can autocomplete things. On some shells, if it's set up right, you'll be able to see a preview. By default, you won't. So you just hit tab, and then you can cycle through the list of all the things that you can autocomplete with. The history command is how you check all the commands you've run so far that have been cached. And then Control-R is, it'll give you an option, it'll give you a prompt where you can search through your history and see different commands that have the string that you typed in it. More tips and tricks. 2 exclamation marks is rerunning the previous command. Sudo, 2 exclamation marks, is rerun the previous command with sudo. Not in Fish, but in most other shells, this works by default. Exclamation mark 5 reruns the 5th command from your history, and you can extrapolate that to whatever number you want. Exclamation mark thing, or string, whatever it is, reruns your most recent command starting with that string. Caret this, caret that, reruns your previous commands and replaces whatever the first string with the second string. $, exclamation mark. The $sign is how it helps you deal with environment variables. So returns the value of your previous command. And then alias is how you set strings to do things. You can set aliases in your bash RC for them to persist, but otherwise you run alias the string and then what you want it to do. So in this case, with the example, that would set the command ls to be power off tac p0. I've done this before. I did not like that machine. And to end things off, more resources if you want to dive deeper into Linux, because this is very much just an intro. You can check out previous year's presentations on the RITSEC YouTube. You can check out the Linux kernel documentation at this link here if you want to read the source code. Once again, go to VRig. It's a great time. And yeah, really, read the man pages. Get used to just understanding how the man pages work. Learning more in general, systemd versus runit. How processes are managed. By default, you'll use systemd. I prefer run it. You can install a Linux distro as a fun side project to help learn more. A lot of people will try that, find they don't like it, and stop. But you do it and you find you enjoy it, then you have a new operating system, and it's fun. And you don't get stuck on it forever. And learning what kernel modules do, diving into kernel space, diving into the Linux kernel itself. Most of what we learned today is in user space, what you can do as users, but there's a whole nother layer at the kernel level. And it's really fun. Once again, go to VRig. And that's it. Any questions? Nope. All right. Thank you.
Testing. Okay. Thank you, Odessa, for the wonderful presentation. It's demo time. I don't know where Owen is. Is Owen here? Tech lead Owen. All right. I don't see him. But if you have any questions, you guys feel free to like raise your hand or come to me or come to anyone that seems like to know what they're doing. Yeah. It's not dropped. Oh, okay. Demos are not dropped. All right. Am I the only e-board person here that's like staying? That would be funny if I was. All right. I don't think demos are dropped yet. That's unfortunate, guys. Camden, when did you get here? Were you here this whole time? Okay. There's no. Oh, hold on. He said he's out of class in 5. All right. We'll let you guys know when demos drop. So stay tuned, guys. Stay tuned.
Hello. Hi. All right. Are the demos there for this week? Has anyone checked? They're there? Okay. So I got into VM download in Easy One. It's going to take a little bit. They're all on the VM this week. The password is not here anymore, but you have to log in through student. The password is password, all lowercase, and then you should be able to do them all from there. If you have any questions, feel free to ask. Good luck.
Hello? Is there who's in ops here that's a grizzled member of ops? Here, Adam, I need your help.
So, guys, as you're doing the demos, read all of the instructions very carefully. Okay.
So say there's pizza outside, just got here, and just make sure you sign it.
Okay. Excuse me, there's pizza outside. Just make sure to sign up, okay?
Hello, hello. For the demos for Medium 2, the flag in the system, I typed it in wrong. So if you got the flag for Medium 2 and it didn't work, try it again. I fixed it. Also, it's the password for the Dan account on there. It won't work, but you shouldn't need it. But if you failed, if it didn't work when you submitted Medium 2, try it again.
Hello. All right. We good? All right. What?
Camera's like right here.
Oh, yeah. Hello, everyone. How's it going? That's great. It's now time for research. Get excited. Yeah. Alrighty. So just a few a few announcements. If you're interested in presenting, presentations.ritsec.club, ideas.ritsec.club for some ideas. You want some free stuff, some free prizes, do some presentations, make some blog posts. If you want to sign up for the blog, go through there. Depending on how long your blog post is, you'll get more points. Announcements. Sign in if you haven't already. If you're not in the Discord, I'm sure you're probably all in the Discord by this point. I hope. The calendar, all this stuff, mailing list. Follow our social medias, and everyone clap it up for the sponsors. Okay, thank you. All right, some cybersecurity news, some stuff that I found interesting this week. We got memory integrity enforcement, Apple with their new memory integrity software. Yeah, and also the NPM supply chain hack, which affected the NPM package manager. So, the memory integrity enforcement, whole name, whatever, from the Apple article. So, essentially, as Apple security engineering and architecture claims, there's never been a successful widespread malware attack against iPhone. And so Apple has some great systems in place for securing iPhone, iOS, all that. And despite that, there are still occasional incidents where threat actors, typically state actors or mercenary hackers, which are either people sponsored by other governments, like the Chinese government, or groups that are specifically paid to carry out these large-scale hacks. They can still affect very small groups, but these are very expensive attacks, which take a lot. And so, just to further strengthen their security, Apple has been working on this memory integrity enforcement system, which will essentially target buffer overflows and use after free exploits, which are these very specific exploits that use memory essentially to carry things out. So just some diagrams that they went over talking about how it worked, which I found pretty interesting. In the top left, there's an out of bounds request. So if you don't know anything about it, about how buffer overflow attacks work, essentially you will write something to memory, and if you go over the buffer size, which is like a size for how much stuff, if you have a string, for example, and you're fitting it in somewhere, and you go over the size, if it's not properly handled, you can go essentially out of the memory region into somewhere else. And so attackers can use that to execute stuff, affect other areas, and essentially they set up this tagging system where it's like certain memory areas are allocated with special tags, and if you try and go out of that region, it will essentially block it because the tags don't match. In the bottom left example, after you free that memory, so you have memory, and then at one point you may say, I don't want to use this memory anymore, and so that can be collected. They have it so that the tags will properly change, so if you had something that lingered afterwards and tried to access that same region, it would also be blocked. On the left side over here, there's a whole chart of them showing these attack chains, which essentially were blocked by their system. So they worked in collaboration to create this thing. It's all EMTE, which is the Memory Integrity Enforcement. I forget exactly what it stands for. But there's a whole article on it. I linked it in the resources. So if you're interested, I would recommend giving it a read. It's pretty interesting what they did. Next up, the NPM supply chain hack. So for those of you who don't know, NPM is a package manager. So when you're working with JavaScript, if you want to install some packages to go along with it, you'll use NPM install whatever. And so there was recently a hack which targeted packages with roughly 2 billion weekly downloads. So these were some pretty massive packages. Essentially what happened, let me skip to where it is. Okay, here's the whole overview of it. So essentially attackers sent a phishing email to a bunch of developers that worked for NPM, essentially telling him oh, you need to reset your password. And one of these developers actually ended up falling for it. And so They ended up stealing the credentials and the 2FA token from this developer, and using that, they were able to push essentially malicious code to npm packages, which then people will go and download, and then through that they had some malware, which was essentially trying to scrape for crypto and then try and steal money from that. So that's like the whole walkthrough of the whole thing. And I also, what I found just like makes this interesting, especially for like freshmen, is like this is like how a lot of hacks like occurs through phishing. It's not necessarily like some crazy exploit. It's sometimes just a person falls for something, and that can lead to like larger down the line effects of people just trying to steal money. In the end, the npm developers reverted the changes after like I think it said like roughly 2 hours, so it's fine. I'll go over the damages later. Here's a full list of all the packages that were affected. So these were some pretty massive packages. So there were a fair number of downloads during the time that they were infected. And as you can see on the left over there is what the phishing email looks like. And so it looks pretty legit. Like there's not a lot of signs that would give away that it's fake. These emails are getting like very professional nowadays, so you have to be like very careful. On the right, there's that bottom line, the line 12, is malicious code, and as you can see, it's like obfuscated when they pushed, so you can't really tell that anything was wrong. And so when it was pushed, like people didn't really question it or anything, and so it was able to get through without issues. Now this is just a random fun thing I thought that maybe we could do. So those of you that don't know what phishing is, that is that process I described with like using emails or other things. And this is just a Google quiz about phishing. So if I just put in some info in here. Okay, so these are just some examples of emails that may or may not be phishing. So just around going around the room, everyone that thinks it's phishing, raise their hand. This one looks pretty legit. Everyone says they say this is legit. Phishing, raise your hand if you think it's a legit email. Unsure? Okay, well, we'll say it looks legit. So this is actually a phishing email. And if you look at the link where it goes to in the bottom left, drive -- Google is not actually legit. So some of these emails are like getting to points where like it can be really difficult, and even professionals can fall for stuff like this. Here's another one with Coca-Cola. Do we think this is? Raise your hand if you think this is phishing. A lot of phishing. Yeah, this one's a phishing email. If you look at the email address that it comes from, it's pretty random. So that one is kind of a giveaway. Let's do like one more. Okay, PayPal, invoice, saying $600. The formatting looks pretty good. If we look at the email, service@paypal.com, that seems pretty legit. What do we think? Raise your hand if you think this is legit. Raise your hand if you think this is phishing. Okay, a lot more for phishing. Yeah, this is also phishing. If you look at the note, there's just some stuff that doesn't really add up about it. So yeah, you can. I put a link to this at the end, but this is just a sort of fun thing to go through and look at phishing. And it's just like kind of crazy how far they've come with phishing emails and how it can affect even professionals in the field. Okay, yeah, there's the chart of everything where it went through a person and then down into the actual software where it affected users. Now, the massive consequences. Do we have any guesses for how much damage this caused? Any millions of dollars, Luca? A few hundred? Okay, let's see. Roughly 5 cents of Ethereum and $20 of a meme coin. Pretty big. I don't know like the reason why it was so small, but for whatever reason, the actual like effect was like tiny, so okay, yeah, so there may have been some reasons. Yeah, so there may be some reasons under my sources if you want to check out some of them. The one with Akaido and Security Alliance did a good job covering it. Also, there's a video, the largest supply chain hack, whatever, by John Hammond, which is a great one out, a great video that I'd recommend checking out, where he goes more into detail of like what happened, why it didn't really succeed, all that. So, all right, now for the actual research. Without further ado, James Gill with Ford Internals.
All right. Cool. This works now. Oh, it's delayed. Okay. So this is a talk about what I did. This is mostly a project over the summer. Reverse engineering Ford vehicles. This is about car hacking, right? And specifically, really modern vehicles, right? So sort of an introduction to sort of general automotive security, right? First off, terms are often conflated in this field. ECU. Most people have probably heard the term ECU before, I think, but it means two different things, and that's kind of confusing. It can be just the engine control unit, or it can be just any module in the car, like at all, just an electronic module. So anyway, that's just sort of general. And there are two separate systems that typically older vehicles have had, right? You've had like the infotainment system, and then you've had maybe the control system that does like the engine and like the power, right? And those are usually, or previously usually, two separate systems. And so you saw there have been a lot of exploits on infotainment systems using stuff like Bluetooth exploits, stuff like that, but there haven't been that many on the control sides, and also they were rather separate. And so with automotive security, there are a lot of interesting attack surfaces. I'm not talking to the microphone enough. Bluetooth stack, USB, Wi-Fi, cellular, but also physical attacks like through the CAN bus, and now in newer vehicles, Ethernet, right? And if you do compromise a vehicle, you can do a lot of cool things, like drive it around, right? Because the throttle and the steering, those are all electronic. So if you can compromise that, you know, you could like remote control this giant truck or something, you know, that sounds kind of cool, right? But there's also stuff like comma.ai, right? That's like an open source. You put like a little dash cam thing and, you know, is open source self-driving, right? Also things like engine tuning, stuff like that. There's lots of reasons why you might want to find an exploit even in your own vehicle. I was just putting pictures of, this is the vehicle basic we're targeting, this blue Ford Maverick. Looks kind of gray in that one picture. Right, really modern vehicle, 2025, and so they're using lots of these new systems. Let's see. So what's Ford really doing right now, right? Most auto manufacturers are sort of doing the same thing, but we're transitioning to EVs, right? Like that's F-150 Lightning. We have apps to remote start the vehicles. And one of the more important things for this is we now have over-the-air software updates, right? Like I know Tesla sort of pioneered this thing, right? But cars get software updates now. It's not just how you bought the vehicle.
And that's a really interesting thing, right? Because they update modules that like drive the car. Well, what, you know, that just sounds interesting to me, right? Yeah, everyone wants OTA updates, and that means that vehicles are always connected to the internet, right? All Ford vehicles come with a cellular modem. That cellular modem is always 24/7 connected to the internet. And you're also blurring the lines between these infotainment and control systems, right? Tesla, Rivian, they all have a centralized architecture where there's just a single powerful computer like in the middle, and that controls everything. Legacy automotive manufacturers like Ford tend to not have that as much right now. In theory, they're distributed systems. Like if your infotainment module fails, in theory, you can still drive the car. You know, if your advanced driver assist, your self-driving modules, if those fail, you can still have basic functions. It's all separate computers doing their own sort of job, right? So Ford, as part of that, created FNV is their new architecture. Am I gonna? Yeah, here we go. This started in 2021. They announced it in 2020. Is this new architecture I'm talking about? And basically, they call it the fully networked vehicle 2.0. They didn't have a 1.0. They just called it 2.0 from the start because, I don't know, marketing. And basically, that's where they introduced a bunch of new, well, networking basically between all the modules, right? This is where they introduced Ethernet, and this is where they introduced a whole bunch of faster buses like flexible data rate CAN, which I'll get into in a bit. And then they've had more, they've been building upon that, right? So in 2023 with the F-250, don't know why they picked that vehicle to introduce it, they have FNV 3.0. And this one supports having an Android automotive infotainment system, right? So you're running Android on the car itself rather than just like Android Auto, like CarPlay type stuff. And also it has some more security features like Tron authentication, which I'll also get into. Let's see, what was I saying here? Oh yeah, so sort of central to these new architectures is something that they've been calling the gateway module. And cars have had this for a while. For security reasons, right, cars have multiple networks on them. So they separate things that are like maybe less important, like say the door locks, onto their own network. And then they have more interesting things like the engine has its own small network and it's sort of separate. But sometimes you need to send a message to the entire car. Things like, you know, you're turning the ignition on. Every module needs to wake up all at once. So they had this thing called the gateway module, whose whole job was to sit like a router in like, you know, networking, and just copy messages across the different buses. It was originally behind the OBD2 port, also because it needed to copy messages from the OBD2 port to the different buses for diagnostics. But when they added Ethernet, they made it this whole big module, and it sits in the center of the dash, this metal module they call the ECG, Enhanced Central Gateway. Yeah, that's what they introduced with FNV 2.0 in 2021, this new silver module. And that's basically what I'm going to be targeting here. This is all the networks they have. It's quite a lot. Well, each of those is showing the changes sort of with the different variations of this architecture, right? You started with FNV 2.0, which had a lot, like the MS, the HS, and the FD are different speeds of CAN buses. MS is very slow. And they've had that for a while, and they use it for slow things like door locks. HS buses are faster, and then FD CAN buses are even faster. Note that when I say fast here, FD CAN has a max of 2 megabit per second, so it's not that much data. But really, the important thing about CAN bus, right, is you're sending repeated messages. So really, things are scheduled in time windows. You're sending something like every 20 milliseconds or something, like just repeatedly forever. Like that's how these systems work. They're less individual packets and more just a repeating message that has a changing value over time. So anyway, yeah, they changed all the networks around for the different years for reasons that aren't always entirely clear. But clearly they're adding more of the faster ones and getting rid of the slower ones, right, is the general trend. But also an important thing we have here is Tron. I don't really know what Tron stands for, but it's it doesn't really seem to stand for anything. But anyway, it's, or maybe I have it somewhere. Anyway, that's they call it encryption. It's not really encryption, it's message authentication. They add a little HMAC tag to the end of every message so that you can't forge them. Now, some auto manufacturers cut in, the problem with CAN bus messages on the older MS and HS CAN standards is they have a fixed length of 8 bytes. That's all you get. So Some manufacturers chose to cut into that 8 bytes and add a message authentication tag to that, but that means you can't send very much data in each packet. So Ford decided, you know, it's not that important to us. We don't want to cut down on the data. Instead, we'll switch to using FDCAN. FDCAN has double. You can do 16 bytes. So they just said, we'll keep it the same length. We'll have 8 bytes of data, 8 bytes of HMAC tag on FDCAN only. And so we'll only secure the FDCAN buses. The HS buses and the MS buses, well, you can still sort of forge messages on them. But that's not that much of a problem. Usually they moved all the important stuff off the HS and MS buses. They also have a couple other architectures that they mention offhandedly, but like these are the main ones that are shipping in vehicles today. There's an FNV3 AV, which is really interesting. They use that for their autonomous vehicle platform internally, like the fully autonomous, like that they're developing for like robo-taxis and stuff. I mean, basically that just means they have a whole bunch more modules with more sensors, and they like doubled the amount of Ethernet. Like there's like 10 Ethernet ports on the module instead of 5. You know, they had FNV 4.0, which was going to be like an EV native sort of platform, right? There are a lot of different choices you could make if you're making an EV native platform. Like all modern Fords today, even the EVs have a push to start button. If you're going EV native, like Teslas don't have a push to start button. They're just always on. You get in and drive. That was maybe what they were going to do, but then Trump became president and they decided to cancel that, like just at the same time, maybe unrelated, who knows. Yeah, FNV4 I guess is not gonna happen, maybe? Not really clear. This is the module I'm targeting, right? And I actually have it up here as a physical prop. See if I can. All right, can I get this maybe in the camera too? But you know, it's just this metal module. It has a bunch of connectors on it. You can see I took it apart here in the picture. And basically, it serves, I already mentioned the purpose of this gateway module, to copy message across to function as a router, right? And it's a central part of this new architecture. There are a couple versions of it. There was the ECG1, which was the first thing they introduced. It had like from NXP, their IMX6 ARM processor, and like a coprocessor that ran. There was one like on Power architecture and one that was on some other Renesas, I don't know, some other architecture for their coproc running like a real-time operating system. But anyway, then they switched. That was running QNX, by the way, which is an operating system for embedded stuff by BlackBerry. But then we have the ECG2, which is what I'm actually reversing, and they switched using Linux. Yay! So that's a lot easier. And there are also the coproc is now like just an ARM processor, not a silly Power IBM architecture. So that's much easier to reverse. So that's why I'm targeting it. And they've actually got a custom chip from NXP. Do I have a photo of this? Yeah. Basically, they got this custom chip designed by NXP for basically just their use case, and it has like a whole bunch of cool stuff. Like it has the ARM Cortex M7 cores. Like I don't know if you've ever like done like embedded microprocessor stuff. Like those, that's what they run their RTOS on, and they have like the bigger ARM cores running Linux, all on the same chip. So they don't have to have two separate chips. But also it supports like a crap ton of Ethernet and a crap ton of CAN buses like built into the chip itself. And a whole bunch of like hardware security engine stuff. So they keep their keys in like hardware. And like the cores are all lockstep to prevent fault injection. Like they really tried to make this secure. Here's a photo of the board like sort of labeled, I guess. You know, there's this, A is like the CAN bus connector, right? There's a whole bunch of CAN buses connected to that. C is where the Ethernet's connected. This is the LT version of the board. HT version of the board has that B connector also populated. That's just more Ethernet. They use that for the autonomous vehicle stuff, as I mentioned. You know, you have that main SoC, 1, and then 2, you have that that chip it's really big, but it's just an Ethernet switch. Like as big as the main SoC is an Ethernet switch because they have like, you know, 10 Ethernet networks they need to switch. Yeah. Also, it's not normal Ethernet. They use this quote-unquote Ethernet master connector. It has 5 Ethernet ports in one, and you'll notice something about them. They only have 2 wires. So that's pretty interesting, right? Yeah, this is automotive Ethernet is apparently a thing. I didn't know. It's 100 base T1 instead of TX. They also have 1,000 base T1. They can do gigabit Ethernet over 2 wires. Yeah, I just thought that was interesting. but you have to get a special adapter for that, and I had to make a special cable. But I guess shout out to T Connectivity, the company that makes the connectors for Ford, will give you free samples of any connector. So I mean that's pretty good. But you have to crimp them yourself. That was annoying. Yeah, their modules connected. Probably spending a bit too long on little details, but you know, there are modules connected to Ethernet. You know, you have the IPMAs, the image processing module. The APIM is what they call the thing that does like the infotainment on the dash. TCU is the thing that has cellular. You get the point, right? This is like my benchtop setup right now. You know, it's got a Raspberry Pi there connected to this 1000 base T1 to base TX converter because, you know, the Raspberry Pi doesn't have automotive Ethernet natively, obviously. You know, it's just a media converter. And like an OBD2 adapter, and I made a custom wiring harness to convert it to OBD2 just because, you know, I needed CAN bus, and that was the easiest way to get it. This is the old architecture diagram. I think I have some, labels. But basically, this is the old pre-FNV way they layouted everything. You can see there are a lot of electronic modules in vehicles. I didn't maybe think of that there are this many before. And they're sort of segregated, right? You can see there's like the powertrain modules I highlighted in blue there. The infotainment system stuff is in red. And before the infotainment system, the APIM there, you can see it's in orange, had like maybe a bit more access. It could access like 3 of the different CAN buses, including the powertrain CAN bus, which was maybe a minor concern for them, right? That you had direct access from the infotainment system, which is, you know, the thing that most people maybe compromise to the powertrain network. And remember, before this, there was also no message tagging. So if you could get control of that, you could forge messages on that bus. And that was problematic. So we're not doing that anymore. Now we have FDCAN, and you can see there's a much clearer segregation. The APIM has access to nothing else except for the other sort of infotainment things. It's not connected to any other network. It's not in a privileged position. Instead, there's this gateway module, which is now all privileged and has access to all the networks. But it sort of acts as a dumb router in theory, so maybe that's a bit more secure. And then, you know, this is when also they started upgrading things to FDCAN, which is like the faster speeds. Yeah. Then we have sort of this one, FNV 2.1. They split it out into 2 diagrams for some reason. But basically, yeah, sort of the same thing, except there's more FDCAN buses. And this is when they introduced the message authentication, this revision specifically. Yeah, that's sort of boxing up things. You know, there's the advanced driver assistance system. That's the IPMA. It does like the self-driving type stuff. And you notice it has a direct line to the power steering control module. I guess just, you know, for safety reasons so that it doesn't accidentally like break that connection and lose control of the steering. So it has like a dedicated wires directly to the power steering. I had some slides on the Ford part numbers. I don't know if that's that interesting, but really they use a very strange system. That's really hard to figure out what they mean. But yeah, they have like what vehicle it came from ish and what year it came from ish, and then a section of the part and a number ish, and then a variant and revision ish that sometimes means a revision, sometimes it means that they use the same but slightly different in different vehicles with like a different config. All of this is very loosely defined and they break the rules all the time. There are like a million exceptions. It's very annoying. So basically, if you want to order parts for Ford things, you just have to call a dealer because they have like an internal database that has some of this information, and it's not like public anywhere, and there's no way to get the same information a dealer has that I have found. I tried very hard. There is just not a good way. Though there are like some things, there's a secret API I found that can look up the quote-unquote service part number and the engineering part number and like cross-reference them. They're 2 different part numbers for the same part sometimes. When you want to replace it and buy it, it's a different part number from what's actually written on the part. So yeah, you need this secret API to like look up between the 2 different part numbers. So that's, yeah. Also, the parts websites based on this simple part thing are better than Ford's own part websites sometimes. Don't really know why. here I was going to do a basic thing about looking at Tron authentication, right? So this is like just a message in a CAN bus decoder, right? For I think this is like lane keep assist messages. Yeah, lateral motion control. But you can see it's 8 bytes long, and then all those bytes, that's the message authentication tag, right? Ford did not want to sacrifice and cut into that message. They kept the messages exactly the same. They just added on these 8 bytes here. Other manufacturers did other things, and they just like cut into their, like they made shorter message authentication tags and cut into their payload. But Ford didn't want to do that, I guess. Oh yeah, Trusted Real-Time Operation Network. I guess that's what TRAN stands for. Huh, I forgot about that. Anyway, SecOC is a thing by like the Society of Automotive Engineers or something like that. It's like sort of a standard, but like not very well defined, because they basically say that automotive manufacturers can do like basically whatever they want. Like they can make it like different parts of it different lengths, which is how Ford's is 8 byte long. But I know some other manufacturers are like 4 bytes long or 2 bytes long. Like they get basically a variable amount of security depending on how much they think, I guess, people are going to brute force it, and how long they think it needs to be, and how much they're willing to sacrifice. It's a trade-off, I guess. Yeah. So this is like sort of diagrams. You know, you have a secret key. They keep that secret key in like a hardware enclave. So in theory, you can't extract it. Key distribution. You sort of have the Ford cloud, and they have this magic database of all the modules they've ever produced. This is also, I think, sort of a right to repair sort of issue. You can't pair modules to a vehicle that aren't like official Ford modules in their database, because the official database needs to give you the keys. Like they're sent directly from the cloud and unwrapped in the hardware enclave. So yeah, that's like, you can't use modules that aren't like official Ford modules, I guess. At least without breaking the system somehow. Yeah, did I have some other things? Oh, that's just doing an animation of the little keys there. Okay. Yeah. What was I going to say? Oh, yeah. How do dealerships configure modules? I was just going to go over this real quick. We have the Ford Diagnostic and Repair System, FDRS. It's an official Ford tool. You normally have to pay like a ton of money in licensing, like thousands of dollars a year to use it. That licensing can be bypassed. So, yeah. And basically, that's also how you do, like if you want to add a new module, that's how you talk to the Ford cloud to get new keys distributed to all the modules, is you have to use that tool. There's the Ford PTS. That has all like the manuals with all the like the fancy diagrams I had before. A lot of them I stole from PTS. You also have to pay for that. But luckily, you can pay just $20 for like 72-hour access, and then just scrape every single manual page on it and then save it for later. And that's, yeah, that works. I mean, it's just static manual information, not like you need it all the time. And there's like ForScan is what they call it. It's like a third-party software made by some sketchy Russian company, but like it can configure a lot more stuff than the official software can in most cases. Stuff like you can configure a module to be in a different, like to think it's in a different vehicle than it really is in, which unlocks features that maybe never were even part of that vehicle to begin with. Especially since they reuse a lot of modules like between Ford and Lincoln, so you can sometimes get like Lincoln features that are like Lincoln only in like your F-150. Like, you know, you can reconfigure things. Current state of things, what I'm doing now, I'm running that Gateway Modules OS. You know, it's just Linux. I'm running it in like QEMU, so I can sort of attack some of those things because, yeah, I mean, obviously it's easier to do something in an emulator because I don't actually have like shell access to the device yet. There are some interesting attack vectors, right? I have that Ethernet adapter, so I can plug into it, send packets at it. There are a whole bunch of open services, you know, listening on ports that are like they wrote themselves in like C. So I'm guessing there is hopefully a vulnerability there somewhere. The one problem is they actually did like Linux like properly. They're using SE Linux to like configure like secure profiles for every process. They're also using DM Verity to make it read-only. They use like a squash FS image that's like completely read-only. And so, yeah, you can't like modify the OS. Yes, question? They call it Wind River. Oh yeah. Repeat the question. Is this like some custom Linux? Yeah. I mean, it is using components of like a lot of normal Linux. Like it's using like systemd and stuff. But they call it Wind River Linux. Apparently, that's like a company that does like contract like custom Linux stuff, I guess. Yeah. I mean, it uses components, but then a lot of custom stuff that they ported over from their like QNX operating system. Like they just copied and pasted a bunch of services. That's all the stuff you see in the log there is kind of tiny. It says like cat A, cat B, cat C. Anything that says category like that is copied from QNX. Anything that doesn't is like a native Linux service. They've also got like a custom bootloader, I think that's in my slides, involved that like is kind of, that also might have some vulnerabilities because it looks entirely custom and it communicates with Linux over a custom file system and that they implemented in user space using Fuse. I would like to question that, but that's just what they did. Yeah, right now the annoying thing in QEMU I need to figure out how to disable is there's like a watchdog type thing that like is very mad at me because all the services are like complaining that they're not actually in a vehicle. You know, it tries to talk to the powertrain control module and it can't, and it's like that something's wrong, I better reboot. So it does that every 2 minutes, but I could probably figure out how to disable that. Haven't yet though. Hasn't mattered that much. Yeah. I think that's all I had. I just had some photos. Oh yeah, this is how I eventually planned it. Like before, I've been using the eBay modules like that I got from eBay. It's really cheap to get F-150 modules, even for like 2024, 2025 modules, just because F-150 is like the most popular vehicle and there are many of them crashed. So, you know, that module MSRP is for $2,000, but you can get it on eBay for under $200, despite it being basically brand new. So that's fun. But when I eventually attack a real vehicle, probably I'll try and attack, there's just behind the seat here, this Ethernet plug that's really easy to access. That would be really nice if I could attack there and not disassemble the entire center console. Yeah, I think that's basically it, unless anyone has questions. Also, I have this Discord server where I just dump information in. There's a lot of information there. If you want to get a copy of like the Linux and emulate it and like try and attack it, you know, you can. I have a GitHub repo that has the scripts to like emulate it in QEMU. Yeah. Any questions? Yeah. Unfortunately, they do have a bug bounty program, but it doesn't pay bounties. Like it's on HackerOne, but it just I haven't seen anybody actually get bounties from it. So I've just been doing this mostly for fun because I want to like hack my own vehicle and like maybe use the Com AI stuff. Maybe if I found something severe enough, I would report it to them and see if I can get them to give me something. But like, yeah. Any other questions? Okay, you wanna?
I was going to say, in the same vein, what is your ultimate goal besides just fun? Like, can you compromise message authenticity of that Tron protocol you're talking about?
Yeah, basically, I figure twofold, right? If I can get code execution on the gateway module can forge all the messages it wants because it has to. Like, that's how it routes messages between the different networks. And it would be really cool to get like that open source self-driving stuff working. To do that, I need to forge messages like from the self-driving module. So that would be kind of cool if I could do that on my own vehicle. That was basically why I started doing this.
And I have to ask, can it run Doom?
I mean, yeah. I mean, the newer versions literally are just running Android on the head unit. You could just. I mean, I think you might have to root it or something, but you could probably just like run Android version of Doom on it.
Is there a specific avenue you're trying to go at to attack that gateway module? Like, are you trying to go through the main like UI portion?
No, because I mean the infotainment system. It just seems like it's indirect, right? Because even if you compromise the infotainment system, it is a separate module. It's just connected via Ethernet, so I'd still have to like do like lateral movement and compromise the other one. But since I have physical access, I can just plug directly into the gateway module and attack it directly via Ethernet. There are a whole bunch of protocols it runs that are custom. There's one they call Token Manager for so-called debug tokens. Basically, Ford sends over a TCP socket these magic like signed messages, and it unlocks a whole bunch of debug features like ADB. They use ADB even though it's Linux. So, you know, if I could figure out a way to forge those debug tokens or like break the parsing of the debug tokens so it let me unlock that, that would be cool. We'll see. That
You're more focused on finding like a physical attack, like if you already have physical access.
yeah, because I mean it's for my own vehicle, so. But there is, like I mentioned, that photo of like this Ethernet connection goes directly straight to the gateway module. So if I could like plug in there and attack the gateway module over Ethernet, that would be really easy from a physical perspective because it's just like behind the seat. Okay, what's your question?
Okay. Do you think it's more secure to use a key fob, you know, like remote unlocking stuff, or an actual turnkey? And if so, where would you store it?
I mean, in all cases, right? It's okay, yeah. Do you actually want to answer that question? I mean, basically, in all cases, the same module is doing the ignition process. Like, there's just a module that, when you have a physical key, it just like because there are trims that still have physical keys. You know, there's a transponder in the physical key, and so that same module does it even if it's like keyless or if it has a physical key. The actual turning of the key does basically nothing. Yeah.
Bye, stream.